Okay, this is a little section on experimental design. When you're doing some research, your methods need to firstly give you the best chance of finding out the effect you're looking for if it's really there, and it also needs to be fair. So you need to be aware of two different ways you could actually go about a comparison. Okay, one would be a matched pairs design. So in this particular case, we want to know whether you can solve a jigsaw quicker with or without noise, or whether it's exactly the same time with the noise as without the noise. So one way of doing this is to have one group of participants and get them to solve jigsaws with the noise and without the noise and compare between the two. So that's just one sample doing things twice. So they're matched pairs because we get two observations from each individual and we can compare those directly. Whereas independent samples would mean we take two completely different groups of people and give one group a jigsaw to do with the noise and one without the noise and make the comparison. Now, one of these designs is more powerful, if we do it right, at detecting the difference. And the reason for that is, if we use independent samples, completely different people, then it may be that some of the individuals in one of the samples just happen to be better at jigsaws than the others. So that gives us some kind of variation in the experiment that could cause us to miss a genuine effect. Whereas if I'm using matched pairs, then I'm comparing for each individual their ability to solve the puzzle with the noise and without it, and so therefore there is no extra variation comparing two different people's jigsaw solving ability because it's the same person each time. So the one that should be better at detecting the difference is the matched pairs design. And the reason is that it should be better because it should not be affected by the variations in different people's ability to solve jigsaw puzzles, because I'm comparing each person with themselves and not with some other random person who might be better or worse than them at jigsaws. Now, this does mean I need to be really rather careful because I needed the comparison now to be fair. So now, rather than setting up two groups and giving them jigsaws and the only difference in the conditions being the noise or not, I'm now giving each person two jigsaws, or it could be the same jigsaw twice. But I probably shouldn't make it the same jigsaw twice, because if I did, it might be easier the second time round. So I now need to find two jigsaws, and I need to try and make sure, if possible, they're the same difficulty. I could test out these jigsaws to make sure the difficulty is the same, but even if I do that, I should probably mix things up. So I should probably randomize which jigsaw goes with the noise, just to offset any possibility that one jigsaw is easier than the other. And the other thing I need to watch out for is which jigsaw they do first, because it could be the second time round they could be a little bit bored with jigsaws because they've just done one. Or it could be, actually, they've just practiced doing a jigsaw, so the second time round they could be better. I don't know, but I need to randomize that as well. So I need to randomize which jigsaw comes first, and I also need to randomize whether the noise comes first or whether the noise comes second. So I need to randomize which jigsaw is solved first and whether the noise is played for the first jigsaw or the second jigsaw, and I need to do different things for different people so that all of the combinations come up roughly equally often. So there are these precautions to think about when you're designing your experiment. Now, matched pairs versus independent samples, what we've been talking about is the sign test, and the sign test and the similar one to it, which we'll do next, which is the Wilcoxon sign rank test, both work with matched pairs. For independent samples, it's actually tests 5 and 6 in this booklet, which are the Mann-Whitney test and the Kruskal-Wallis test, which work with independent samples, and we'll talk about those more nearer the time. You can't avoid using independent samples sometimes. We've seen the complications that get involved even with something as simple as jigsaws when you've got to do one and then the other. If you're testing whether a particular set of conditions is likely to make you die, then you can't do that for the same people twice, because the first time round some of the people might be dead. I don't think you'll probably end up in your lives doing too many experiments that involve people dying. I hope not. But there can be all kinds of situations where you can't realistically do the test twice on the same person. So matched pairs testing, although it's great, is not always possible.